Let's look at problems 3 and 4 from various equations too. Just like number 1 and number 2, I want to isolate the square root. So I'm going to add the x to the opposite side, and I have the square root of x plus 3 equals x plus 3. Now, to isolate this x, I need to start by squaring the left and right hand side. To do that, I'm then able to cancel out the square root and the square. I bring down x plus 3. Now on the right hand side, I often see a mistake of students thinking we distribute and get x squared plus 9. No, this means write this quantity down twice. After I write it down twice, I'm able to FOIL. Now I'm going to teach you a real quick trick about FOILing. We could multiply the fronts, multiply the backs, and then when you have the same quantity, that is done twice, when we do the insides and outsides, see how they're the exact same? 3x and 3x. So 3x and 3x is 6x. Let's move everything to the side that contains the x squared. So in this case, I'm going to move everything over to the right-hand side. Combining like terms, I get x squared plus 5x plus 6. And now we can either use factoring, which doesn't always work, or the quadratic formula, which is guaranteed to work, in order to solve for x. What multiplies equal positive 6 and combines to give us 5? That would be 2 and 3, so x plus 2 and x plus 3. I said each quantity equal to 0, and I'm going to solve. And so I'm going to come up with answers of -2 and -3. But at this point in your math career, we can't just assume that each of those answers is correct. So I'm going to grab a calculator, and if it's correct, it will say the left side does equal the right side. Let's start with -2. I have the square root, and now I'm going to substitute in -2 where I see an x. -2 plus 3. I'm going to use the arrow to now move behind the radical. Subtract, and I'm subtracting the quantity -2. If this value equals 3, then I know -2 works. It does equals 3. That means that -2 is a correct answer. Let's try -3. Square root of -3 plus 3, move it in back, subtract -3. Again, does it equal 3? It does, in fact. So we have 2 correct answers. Let's move on to number 4. I'm going to start by adding 2x to the opposite side. Square root of 2x plus 15 equals 9 plus 2x. Just like we did in example number 3, we're going to square both the left and the right-hand side. On the left-hand side, I'm left with 2x plus 15. I need to write this quantity down twice. I multiply the fronts to get 81. I multiply the backs to get 4x squared. And now I can see the inside is 9x. The outside is 9x. When I combine, I said 9x, excuse me, 18x and 18x. When I combine 18 and 18, I'm left with 36x. I want to move everything to the side that has the x squared. And then I'm going to combine like terms and write it in standard form. So I've moved everything on the left-hand side. There's nothing left over here. And now I'm going to combine like terms. There's only one term that has an x squared. And now I'm going to combine positive 36 and -2. And I'm going to take 15 away from 81. And when I take 15 away from 81, I'm left with 66. And I'm going to see, can I factor this? And if I can't factor, if it doesn't come to me real quick, then I'm going to use the quadratic formula. Okay, let's see what we can do here. Well, I personally would probably start by recognizing that all of them are even terms. That would be the first thing I would do. So I'm going to start by going, okay, I'm going to divide 2 here, and I get 2x squared plus 17x plus 33. And then I'm only worried about this trinomial. Why is that? Because I can divide by 2, and 0 divided by any number is 0. So I am only worried about solving for an x value by focusing on this trinomial. Okay, 2 times 33 is positive 66. So I'm looking for 2 numbers that multiply. Remember, we can still solve if factoring doesn't work. And so I'm going to look at my combinations here. So 66 divided by 1. Okay, 1 and 66 does not equal 77. Also, notice they're positive and they're positive. So both terms that I have, if this is factorable, have to be positive. 66, divided by 2, well, 2 and 33 doesn't give me 77. 66 divided by 3, 3 and 22, no. 66 divided by 4 doesn't work. Divided by 5 doesn't work. 66 divided by 6. Oh, 6 and 11 do add up to 17. So 6 and 11. Okay, So I'm going to write 2x squared plus 33. Now in this area, I have a plus 6x and a plus 11x. And now let's use factoring by grouping. So I can factor out a 2 and an x. I'm left with x plus 3. 2x squared plus 6x. What times x gives us a positive 6? Positive 6x plus, oh, sorry, I'm going after this one. That should have been 11. Positive 11x, and there's plus 33. Okay. This is an 11, by the way, my sloppiness. So x plus 3 is going to be one quantity, and 2x plus 11 is the other. I'm going to set each one equal to 0 quickly, and I'm going to solve. I'll do that up here for us quickly. X plus 3 equals 0. Subtracting 3, I get x equals negative 3. And then the same thing, 2x plus 11 equals 0. Subtracting, I get 2x equals negative 11, divided by 2, and I get negative 11 over 2. So now I need to use a calculator to see, is this correct? Remember, we're going to come back up here. So this is the equation that I've been working on, and I want to see, does negative 3 and does negative 11 over 2 work? By the way, 11 over 2 is equivalent to negative 5.5. So let's start with the negative 3. I have the square root of 2 times negative 3 plus 15, move in back of this quantity, subtract 2 times negative 3, and this better equal 9. If it doesn't equal 9, I know negative 3 is not a solution. It does, perfect. Negative 3 is a solution. Now I'm going to plug in negative 11 halves, or I could put negative 5.5 to make my life easier. So 2 times negative 5.5 plus 15, moving back, subtract 2 times negative 5.5, and we get, oh, this does not equal 9. So it's not a true mathematical statement. The left side does not equal the right-hand side. So when I look at these solutions, this would be considered an extraneous solution. We only have one solution for number 4.